Okay, we're back with some more TensorFlow-Quantum content. However, it's not going to be code today. We're going to be reviewing some of the most frequently asked questions for TFQ. So basically, I made this video because, or I'm making this video because I see so many of the same questions over and over again that I thought I'd sort of get them all out of the way in one fell swoop. So this is largely this is based on some talking to people and also on the issues on GitHub. If you make an issue on GitHub, there's a very large chance that I will be the person responding to it. I'm really not sure if TensorFlow Quantum is actually actively being developed by Google, but if you look at any recent issue, you'll see me as the person responding. So I figured, I see all these questions all the time, so let's just talk about them. So without further ado, the first thing I want to get into is how to actually make an issue on GitHub, and this is independent of TensorFlow Quantum. This is just good practices in general, but it's very annoying when I see these on GitHub and they don't have this. And if you look, you can do the is commenter. You can see all the issues I've commented on. And I've even pointed this out to people before on there. The first thing is that you always want to provide sufficient code to recreate the issue. So sometimes people will just link the code that's causing an error, but then if it's somewhere right and they're doing some system where they load data, they train on the data, and now they're trying to do something else. Like I don't have the code to do all the previous steps. So how am I possibly like going to experiment, assuming I don't just instantly know the solution to your bug? How is anyone going to experiment? And so you have to provide a full minimal example. You don't have to give away everything you're doing, but pare everything down to give a minimal example so that, if you're training some, um, generative model, you include toy data set loading. So everything, so basically I can copy some code or really any, maintainer or responder to this. You can copy your code and instantly see the issue. That should be the goal. It's a huge inconvenience if you don't provide it, and in many cases people just won't even respond if you don't provide it because it's a bunch of work to go and recreate this. I have a bad habit of doing that work, but I'm trying to go forward and say, you have to provide sufficient code to recreate the issue. When you put code snippets in a GitHub issue or in GitHub in general, you do 3 of the little I don't even know what it's apostrophes, I guess, backwards apostrophes. Um, that will make a code block. You can type, I assume, multiple languages. I've only actually done this with Python. But you can type a language after that and it will highlight according to the syntax, which makes it much more readable. So if you're doing code blocks, make sure to type Python after those 3 dashes or 3 apostrophes, then your code, then 3 more apostrophes. You don't need to put Python at the end. And this is just super, general, is like, what do you really want? Always include what you really want to do, because a lot of times people ask problems and it's like, what are you trying to do? Because you would never really want to do that. So what are you actually trying to do? Because a lot of times people have an overarching goal, and to get to that goal, they make a sub goal, but that sub goal is totally the wrong direction to go in for the project. But then they ask about that sub goal and give no context. So then you're thinking, I bet they're trying to do this, but they didn't ask that. So if you say, I'm trying to do this with the overarching goal of doing this, then you might be able to see, okay, you're totally, that's a bad idea actually. And then the last thing I'll say is I see so many repeat issues, or I see a lot of repeat issues. Like, look at the issues or Google things first. It's like to not even do the most basic of going through to GitHub issues and make sure to check closed issues too. It is very, inconvenient and annoying. Okay, so now we're actually going to be getting into specific questions for TensorFlow-Quantum. What I'm going to go through in each slide is the overarching idea, the issue, and the solutions. Those are the specific issue numbers. If you go to GitHub, you can check them out. So basically, the question here is, can you use TensorFlow-Quantum on the cloud or with GPUs? GPUs, to the best of my knowledge, are not supported in the current main branch. There was going to be support. You can see a branch for, there's a cuQuantum support, but I don't believe that got merged. But I haven't tried in a while. Multi CPUs can give speedups, and if you want to know how to run TensorFlow-Quantum on the cloud and get a lot of speedups, there's a demo just made for you. So next up, and this is probably the most common issue I see, is I can't install it for X, Y, or Z problems. You can see all of those issue numbers there. The most common problem is people don't have the right versions. For the release that you're trying to do or trying to install, check the requirements.txt. It gives explicit requirements. And like half the time people are like, I have, circ 0.1 and it's not working. I'm like, oh, well, it requires circ 0.13. Like, that's just a basic thing you can check. So always check the requirements. A lot of people try to install the latest version, TFQ 0.7. I generally work with TFQ 0.6.1. That's just a good tip. There seems to be some problems with 7, but it's not consistent. And I also encounter problems if you have an old version of TensorFlow and then you try to upgrade, it's very difficult to get things to work out. So the easiest way to install TensorFlow-Quantum is just to start from scratch and redo the installation. So this will solve like 99.9% of your installation problems, is making sure you have the right requirements, using a 0.6 version of TFQ, and just trying again in a new environment. Windows is not supported. TFQ support for Windows ended at post 0.3. You cannot install it on Windows. It'll get mad at you if you try for a post 0.3 version. If you are on Windows, as I am right now, and you want to use TensorFlow-Quantum, I recommend one of 3 solutions. 1, use Google Colab. 2, SSH into a Linux machine, either remotely or you could even theoretically dual boot or something, or use Windows subsystem for Linux. And that's what I do most of the time. And that's a way that you can run Linux programs without having to dual boot or SSH into another machine. There was some pip install problems. If you're having problems from pip installing and it's just not working out, make sure you've updated pip to the latest version. That solved all of my issues with pip. If you're installing on a Mac M1, the GPU system that Apple has, it's a super pain apparently, even for TensorFlow or PyTorch. Getting everything to work with Metal, I've heard, is very painful. I've never installed it, so all I'm going to say is issue 655, the person who made that was able to post back with a solution that worked for them. So I always redirect people to that issue. So I recommend you check that out if you want to install it on the M1. So this is basically trying to integrate circ and TensorFlow-Quantum functionality. For example, if you try to use TensorFlow or TensorFlow tensors as circ parameters, it'll get mad at you. And there's a bunch of other sort of clashes like that where circ doesn't like TensorFlow, but TensorFlow likes circ, I'll put it that way. And most of the time, these sort of solutions can be found by simply using a controlled PQC layer. So a lot of times people want to do fancy things with their parameters, and what you actually want to do is manage your parameters more explicitly in a custom layer, and then feed them into a controlled PQC. And you can see I've done that many times on this channel and on the quantum computation GitHub repo that I put all of my code on. So this is definitely, you can see lots of examples there. Noise. The best way to, when working with noise, I've found is 1, make sure your channel is supported. Call your get supported channels utility function to see everything that you can do, and then just do your circuit the easiest way that works for a lot of people is just do your circuit dot with noise and then put your channel in that in those parentheses, and that's worked for me most of the time. If you're getting this is a very specific issue, but if you get arithmetic expression outside of simple scalar multiplication is currently not supported, that's an issue because you're trying to manipulate the parameters. This is very similar to the previous circ one. You're trying to manipulate the parameters that are being fed into a circuit. And so really what you want to do as before is do the manipulation in TensorFlow and then use a controlled PQC. Keep the circuit static and do everything beforehand managed in a custom call function. This is extremely similar to the previous issue, but I wanted to call it out by name because it's come up multiple times. There's a question, how do I do X? How do I do, you know, re-uploading? How do I do data re-uploading? How do I change the circuit parameters? How do I do, whatever? 9 out of 10 times the answer is to do a custom layer with a controlled PQC as a backbone. So you can see that in my re-uploading videos, you can see that in my reinforcement learning videos, all sorts of stuff where the answer is usually to manage the parameters, do the manipulation beforehand in a custom call function. Occasionally you will need even more control, which you can do by explicitly calling the TFQ expectation layer or sampled expectation layer or noisy expectation layer. This gives you even more control about what you're feeding in and is usually the solution if you need to vary the circuit structures. How do I save my model? Same as TensorFlow. You can do model.saveWeights and load weights, and this has worked for me. So yeah, basic TensorFlow functionality. This is a great issue that I still reference today in my own usage. If you optimize your circuit or something, or even just initialize your circuit, call the expectation or TensorFlow expectation, and then also get the expectation value using circ, you'll get different values and you'll be wondering what's going on. And that's because TFQ internally sorts the parameters. And so if you take those parameters outside of TensorFlow-Quantum and then use them with circ, you're going to get different numbers because those parameters have been reordered. So if you want to do this, you need to sort them. You can see explicitly how to do this, as I mentioned in this issue 646. But basically, because TensorFlow-Quantum internally sorts them, the ordering gets messed up. And so if you want to use a TensorFlow-Quantum parameters and feed it into all your circ workflows, you need to reorder those parameters. This is a bit of an annoyance. Multi-controlled gates, I do not believe has been fixed yet. There's a stale PR made. If you do multi-controlled gates, it'll often say like, oh, it's not supported. But the hack that works is you can do your base gate dot controlled, and you can specify however many controls, and then you can do on, and you specify the target gate. And this works for me in pretty much every situation. So if you want to do multi-controlled gates or sort of more complex gates, that's a hack that works for me. And that's it. It's a really quick video, but it's been sitting around in my to-do list for a while, so I figured I'd finally get around to make it. So yeah, those were TFQ, FAQ. And if you have any more questions, of course, you can always make issues on the GitHub. Maybe someone from Google will respond or something, or you can, ask in the comments or whatever.